Hello. Audio. Yes, students, just give me a second. Let them check for the audio and video so we don't get interrupted in between the video. Okay, everyone. So welcome to the YouTube of the Charvik Academia, and you have gone through the paper of the chemistry, biology, and maths in the English medium and in the Gujarati medium as well. And for the physics, we are remaining with the discussion of the paper in the English medium. We have already done the discussion in the Gujarati medium. So right now we are discussing the same paper in the English medium. But let me tell you, this will not be only the paper discussion, but we will be also discussing the theories in between, and we will also be discussing that which type of the questions could be asked, another questions could be asked from this theory. So stay tuned, and we are now discussing the 2021 paper of the GUJCET. So let us start without wasting your time. So question number 1, the radius of the innermost Yes, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 raised to minus 11. And what are the radii of the n is equals to fourth orbit. Now, if you want to find the radii of the any orbit, we know that Rn is directly proportional to the n square and inversely proportional with the z. Now, here in this question, they are asking us about the hydrogen atom. And as we all very well know that for the hydrogen atom, Z is equals to 1. So right now we can say that Rn is directly proportional to the n square. So we can place the equation that R1 divided by R of, for which radii they are asking us, n is equals to 4, which is equals to square of 1, which is equals to 1 divided by square of 4, which is equals to 16. So now our radii of the fourth orbit will become R of 1, which is 5.3 into 10 raised to minus 11 into 16. So from these values you can see, you can clearly observe that 16 into 5, which is approximately 80. So your answer will be around 8 or 80. Here it is 10 raised to minus 10 because they have shifted the 1 point. Otherwise the answer is near to the 8. So your answer will be third option. Let us move to the next question. The ground state energy of the hydrogen atom is minus 13.6 electron volt. What will be the kinetic energy of the electron? Now they are asking us for the hydrogen atom, and for that it is a very simple thing that the kinetic energy is equals to negative of the total energy. And if you want the kinetic energy, they are giving us the total energy. So kinetic energy will become minus of minus 13.6, which is equals to plus of 13.6 electron volt. So our answer will become 13.6 electron volt. If we want to go a little bit in detail into this question, so this relation is also equals to potential energy divided by 2. Questions could be asked from this portion also. Okay, let us move to the next question. So, how many neutrons will produce? Yes, how many neutrons will produce for a given following nuclear fission reaction? So, it is a question from the nuclear fission reaction. You just need to calculate these numbers and you need to balance this number. But before that, let us discuss what is a nuclear fission process. So you all know we can get the energy by the nuclear fission process by the fission of the heavy atomic mass elements like uranium, plutonium, thorium. We will just bombard a neutron on the uranium, plutonium or thorium's nucleus, and then this nucleus will be divided into the two parts, and we will also get the another free neutrons, and this free neutrons will further react with the another nucleus of the uranium or plutonium or the thorium, whichever element with which you are doing your fission process. And because this neutron will further process with the another nucleus, this reaction is called as a chain reaction. So let us solve this question. So we have atomic mass 236. Okay, let me write here. So we have it is a 236, and on the other side from the barium and krypton we are getting 144 plus 89 plus we don't know how much it is. So 4 plus 9, that is 13, 1, 8, 12, 13, 1, 1, 1, 2. So it is a 233, and to balance this number we need to add 3 more atomic mass. That means there will be 3 neutrons, 0, 1. So we are getting a 3 free neutrons from this process. So your correct answer will be option number 3. Okay, let us move to the next question. Lifetime of a radioactive element is a 16 years. How much time will it take to reduce its activity by the 14th part? You need to reduce it by the 14th part. If you want to reduce it by the 2 part or the second part or the half, it will take the 1 lifespan of the half time period. After the half time period, you will get it 1 by 2. After another half time period, you will get the half of this, that means 1 by 4. After another half time period, you will get the half of this, which is 1 by 8. And again after another, you will get the 1 by 16. So how much time lapse of the half time period you need? You need 1, 2, 3 and 4. You need a 4 span of the half lifetime period. And one of the half lifetime period is of the 16 years. So your answer will become the 16 years. Also, you can get it done by the equation n into tau 1 half. Okay, let me write it more properly. Yes, n into tau 1 half, where n is 4. How do we get the n is equals to 4? Which is n is equals to n naught divided by 16. You can say it is n naught divided by 2 raised to 4, which is our value of a small n, and tau 1 half, which is a half life period, which is given as a 16 years. So again you are getting the answer as a 64 years. But let me tell you, in such type of the question, you don't need to put the equation at all. You can just get the idea logically and you will get the answer more proper and also quickly than this one method. Okay, let us move to the next question then. What should be the ratio of the neutron and proton for the stability of a heavy nucleus? So what is the ratio of the neutron versus proton, and in order to get a stable nucleus? So ratio of the neutron versus the proton, it should be between 1 and 1.5. And for the first 29 elements, this ratio is very much near to 1. For first 29 elements, and that is why the first 29 elements are very much stable, that you all know very well because you have studied chemistry as well. So now for the heavy nucleus, they are asking us for the heavy nucleus. So you cannot say that for the heavy nucleus the ratio will be 1:1, because as your nucleus is heavy, this ratio will not be near to the 1. Even for the first 29 elements, it is near to 1. After that, it won't be. So now, if you want a stability, you can say the ratio should be in between 1.5 and 1. So let us take the first option. It gives us the answer 2/3, which is less than 1. So it does not fit in our criteria, and hence we can say this is not the correct option. For the second option, the ratio is 2/1, which is more than 1.5. Again, not in our criteria, and that is why it is a wrong answer. 1:1, it is not at all a correct option for the heavy nucleus. So now we remains for 3:2, and 3/2 is equals to 1.5, which is in our criteria. And from this thing you can say that the third option 3:2 is our correct answer. Okay, let us move to the next question. What is the energy band gap for the P-type and N-type semiconductor used to form a LED light to produce a red light color? See, in this question, you need to remember the data of the red color light. How will you get the energy? The equation of the energy is equals to Hc by lambda. Any of the values are not given in the question. But as you all know that h is a Planck's constant, which is a constant 6.6 into 10 raised to minus 34. What is c? It is a speed of light, and speed of light is 3 into 10 raised to 8 for the vacuum. Divide by lambda. Now for the lambda, you need to remember that the wavelength of the red color light is a 650 nanometer, which can be written as a 650 into 10 raised to minus 9. Only this much data you need to remember. If you remember this and this equation, you can easily solve the question and you can gain the mark. Now further you can calculate it by the calculator and you will get the answer of the 1.9 EV. Okay. So next question is, in a full wave rectification, input frequency is a 60 Hertz. What will be the output frequency for that? And they are asking us for a full wave rectification. So you all know it is a very simple and theory based question that for a full wave rectification, the frequency of the output will be 2 times of the input, and 60 into 2 is nothing but a 120 Hertz. So your answer is option number A, which is 120 Hertz. Okay, so next question. In a given following electrologic logic circuit, it behaves at which logic operation? I have said it in the Gujarati medium lecture, and right now also I am saying that this type of the circuit, they are asking it one question from this logic gate from the 14th chapter each year. Please do remember the Boolean expression of all the logic gates. It is a very easy concept and it is sure giving you a 1 MCQ. Okay. So let me tell you in the brief that if you are having an OR gate, the Boolean expression of the OR gate is A plus B. And if you have an AND gate, the Boolean expression of the AND gate is A dot B. And if you have a NOT gate, so NOT gate will simply give you the opposite output. That means if you are giving A, it will give you A bar. If you are giving B, it will give you B bar, whatever it is. Okay, so right now it is a OR gate and this dot represents the NOT gate. So basically this combination, this first combination only, that is a NOR gate. And as we know that because it is a OR gate, the Boolean expression will be A plus B. Now there is also a NOT gate combined with it, and therefore there will be a bar. And after that you are giving this output of this gate to the another NOT gate. And for the NOT gate there will be another bar. So bar and bar of A plus B, it will be only A plus B. And A plus B is a Boolean expression of which gate? It is of a OR gate. And therefore your answer will be second OR gate. Okay. Let us see the next question. The electrical field intensity due to an electric dipole on its axis at a distance x, where on its axis and on the equatorial at a distance y are same. What is the ratio of the x and y? So for this you need to remember what are the formulas for the what is the ratio of x and y for the electric field intensity. So let us say we have a one dipole moment P, and for this dipole moment P, if you need to find the electric field at any point which is at theta, which is at theta and at r distance, the formula for that is under root 3 cos theta plus 1 into kp divided by r cube. And now if you want to find it for the axis line, the theta becomes a 0 and cos 0 is nothing but 1 and 3 plus 1 is a 4 and under root 4 is 2. So for the axis we can say your formula will be 2 kp divided by r cube. And if you want to find it on the equatorial line, so for the equatorial line theta becomes 90 and cos 90 is 0. So this term becomes a 0. Plus 1 under root, that is nothing but 1 only. So for the equatorial line, your equation becomes a kp divided by r cube. So in this question, they are asking you, they are telling you that the axis on the axis and on the equatorial at distance x and y respectively, this electric field is the same. So we can write that 2 kp divided by r is a distance, but in our case the distance is given as a x. so upon x cube, and for the line of the equatorial it is kp divided by r cube, but in our case the distance is given as a y, so it will be y cube, and these both are equal to each other. It is given in the question, are same. So now by equating this both, kp got cancelled out. You need to find the ratio of the x and y. X goes on that side, so you can say 2 is equals to x cube divided by y cube. If you want the ratio of the x and y, take the cube root both the side. So by taking the cube root, we can say on this side we will get the answer, cube root of the 2 divided by 1 is equals to x divided by y. So your answer is cube root of 2 is to 1, which is given in the option number 4. Okay, so let us see the next question. As shown in the following figure, an electron falls through a distance of a 1.5 centimeter in a uniform electric field. The magnitude of the electric field is given, which is 2 into 10 raised to 4. Find the acceleration of the electron due to the electric field, where E is given, mass of the electron is given, and you already know all of these values, whether it is given or not. So we need to find the acceleration. For that we can say force applied, which is equals to ma. So ma can be written, because it is a force due to the electric field on the electron, we can say this force ma will be also equals to qe. And now they are asking you to find the acceleration. Just simply make a subject the acceleration. So acceleration will be qe divided by m, where q, you know, it is 1.6 into 10 raised to minus 19. Electric field, the value of the electric field is only given, yes, it is 10 into 10 raised to 4 divided by mass, which is 9.1 into 10 raised to minus 31. There is no any rocket science. You all know these formulas. These are the very basic formulas of the electrostatic. So now you just need to calculate this in your calculator, as calculator is allowed in the GUJCET, and you will get the answer from this question, which is option number 2, 3.52 into 10 raised to 15, which is your correct answer. Okay, so let us move to the next question. Two large thin metal plates are parallel and close to each other on their inner faces. The plates have a surface charge density of the same sign. This is the important thing. And magnitude of 17.7 into 10 raised to minus 22. What is the E in the outer region of the second plate? So you might be thinking that, sir, we have discussed only the electric field in the inner region of the two parallel plates. So we were talking that about the capacitor. So for the capacitor, you have two plates. One is a positively charged and another is a negatively charged. And if one is a positively charged and other is a negatively charged, you will get some electric field in the inner region, because due to the positive charge, the electric field is in this direction, and also due to the negative charge, the electric field is in the same direction. So both the electric field will add on to each other, and therefore you will get some electric field in the inner region. But right now in this question, they are asking you that both the plates have of the same sign charges. That means you have a two parallel plates. One plate is charged by a positive charge and the other plate is also charged by the positive plate. Now positive charge. If both the plates are positively charged in the inner region, due to this positive charged plate, the electric field will be in this direction. And for this other plate, which is also a positively charged, electric field will be in this direction. So both the electric field will cancel out each other, and you won't get any electric field in the inner region. That is why they are not asking you the answer for this region. They are asking you the electric field at the outer region. So for the outer region, due to this positive, the electric field will be outwards direction, and also for this positive, it will be in the outwards direction. So in the outer region, both the field will add on to each other. Now you should be knowing the value of the electric field due to the positively or negatively charged plate, which is there in your syllabus in the chapter number 1, last topic, application of the Gauss's law, which is a second application, that the electric field due to a fully charged plate is E is equals to sigma upon 2 epsilon naught. And because there are two electric fields and both are in the same direction, we need to add both the electric fields. So it becomes plus 1 more times sigma upon 2 epsilon naught. So now by giving the more simplification, you can get it is a 2 sigma upon 2 epsilon naught 2 cancels out. So now value of the sigma it is given, which is a 7.7 into 10 raised to minus 22, and for the value of epsilon it is 8.8 into 10 raised to minus 12. Just place the values in the calculator and you will get the answer 2 into 10 raised to minus 10, which is given in your third option. Okay. So our next question says that which of the following option gives the dimensional formula of the electric potential, electric volt V. So for that we have a formula, P is equals to V into I, and to get the dimensional formula of the V, we can say V is equals to power divided by current. Now for the current, the dimensional formula is not at all the issue. We can simply write is A raised to 1. But you need to get the dimensional formula of the power. How will you get the dimensional formula of the power? You can take any equation of the power and make a dimensional formula, which is a very easy thing given in the standard 11 chapter number 2. But this particular equation of the power is there in the syllabus of the standard 12 chapter number 3. Okay. So for the formula of the power, we can say power is equals to force into velocity. And the dimensional formula of the force, we all know that it is m1l1t minus 2. If you do not remember even this thing, you can get it by F is equals to m, where A is a meter per second square. But right now I am telling you the formula is m1l1t minus 2, and for the velocity it is meter per second, and meter which is a length. So we will add this into the L. So our L becomes 2 and per second. So it is again a T inverse. So see T minus 2 minus 1, which is minus 3. So dimensional formula of the power becomes m1 L2 T minus 3 divided by current. So it is A1, and this A1 will go in the numerator, and it becomes m1 L2 T minus 3 into A minus 1. So let us match the option. M1 L2 T minus 3 A minus 1. Yes, it is given into the first option, which becomes your correct answer. Okay, let us move to the next question. Find the equivalent capacitance between the 2 points A and B. Equivalent capacitance is asked where each capacitor is of a 3 microfarad. Now there is a circuit which is made up full of the capacitor. So first let me tell you, if they are giving you a resistor, and if the resistors are connected in the series, the equivalent resistance will be 1 upon R1 plus R2. For the series, you need to simply add them. If the resistors are in the parallel, we are discussing the extra theory that there are the series parallel combination of the resistor, there are the series parallel combination of the inductor, and there is the series parallel combination of the capacitor as well. So we are discussing how the formulas of all three combinations and what type of the questions can be asked from these theories. So for the parallel, you can say the 1 upon R equivalent will be equals to 1 upon R1 plus 1 upon R2. Now, if they ask you the series and parallel combination for the inductor, so for the inductor, you can say if it is L1 and L2, we are only talking about the self-inductance. Mutual inductance will be plus or minus 2M. So for this series combination, you can say the total will be L1 and L2. And also by the parallel combination, for the parallel combination, you can say 1 upon L equivalent is equals to 1 upon L1 plus 1 upon L2. But in the case of the capacitor, now you see the resistor and the inductor both behaves as the same way, that if they are connected in the series, you just need to simply add on the value, and if they are connected in the parallel, you need to add the reciprocal values. But in case of the capacitor, if the capacitor are connected in the series, it is opposite to that of the resistor and the inductor. That means in case of the capacitor C1 and C2, you can say C equivalent is equals to 1 upon C1 plus 1 upon C2. So the series combination of the capacitor will behave same as a parallel combination of the resistor and inductor. And now for the parallel combination of the capacitor, you can say equivalent capacitance is equals to C1 plus C2. So you need to remember these formulas and this relation very carefully, that resistor and inductors going same by same simultaneously to each other, but capacitor is behaving something different from both of them. Now here in this question, they are giving us the capacitor circuit. So now for these two capacitors of C and C, both are series. So both are in series. So therefore we can say the equivalent circuit for that, equivalent capacitance for this first and second will be C by 2. And there is one another capacitor given which is in the parallel, and the value of that capacitor is given as a C. And there is two other capacitors which are in the parallel, which are in the series. So C and C, it again becomes a C by 2. So this is how the simplified circuit of the first part becomes. And for the second part, yes, you see, for the second part, the potential of this point and this point will be equal to each other, and due to that there will be no effect of this capacitor. You can simply cut that capacitor from the circuit. So now due to that Wheatstone bridge circuit, we can say there are two resistors, both are in series. So again, due to that capacitor, you can say the total capacitance becomes a C by 2, and for this downward circuit again you can say the total capacitance is a C by 2. Now again make the simplified circuit. This C by 2, C and C by 2 all will add on to each other, because these capacitors are connected in the parallel, and if they are connected in parallel, you need to add the values which we have just discussed. Okay, so if we add the value of C by 2 and C by 2 becomes a C plus a C, so it becomes a 2C. And for this another half part, C by 2 plus C by 2, it becomes a C. Now they are in the series circuit again, so you need to calculate it by 1 upon C1 plus 1 upon C2, or you can say multiplication of both on the numerator and addition of both in the denominator, which becomes a 3C. CC get cancelled out, so equivalent capacitance becomes a 2C divided by 3. And what is the value of the capacitance given? It is a 3 microfarad. So you can say it is a 2 into 10 raised to 3 into 10 raised to minus 6 divided by 3. 3 cancels out each other, and now you get your final answer, which is 2 into 10 raised to minus 6 farad. Okay, the answer is given in the microfarad. 2 into 10 raised to minus 6 is nothing but the micro only. So your correct answer becomes a 2 into 10 raised to minus 6, which is a 2 microfarad, and it is your second option. Okay, so now let us quickly move to our next question, which says that which of the following option is a pair of the polar molecules. So we all know very well that the polar molecules are HCl and H2O. It is a purely database question given in the NCERT chapter number 2. After you are done with the part of the potential, before starting the part of the capacitor, they are giving some information about the dielectric materials and how to get the polarized dielectric material and all of these things. And you also have studied these things in the chemistry, so you very well know that the answer is HCl and H2O. Okay, let us move to the next question. For the which value of the resistor R when the galvanometer shows the zero deflection for the following below electrical circuit? See, this is a purely logic based question. I can say this is a good question from this paper. So now they are saying that the current of the galvanometer is 0. Galvanometer shows the deflection 0, and if the deflection of the galvanometer is 0, what is the particular situation or the condition by which you can say the current from the galvanometer will become 0? So before solving this question, let us revise some theory of the series combination of the electric cells. What happens when you connect the electric cells in the series connection? So if you have connected the electric cells, two electric cells in the series in such a manner that plus minus are in the synchronicity to each other, the total will be E1 and E2, then the total will be E1 plus E2. And if you have connected these electric cells in the series just like plus minus plus, and the EMF of the two cells are E1 and E2, where E1 is greater than E2, then we can say total EMF becomes E1 minus E2. You need to subtract the values, because this first battery is trying to draw the current in this direction, and second one is trying to get the current in the opposite direction. So that's why you need to subtract the values. Okay. So now here, if they are saying that there is no current, that means that the potential should be 0. If the potential is a 0, that means between these 2 points you are getting the voltage of the 2 volt, such that the positive terminal is on the upper side and negative terminal is on the downward side. Why? Because then only there will be the two batteries connected in series with each other, and E1 minus E2 will be 2 minus 2 is equals to 0. So there will be no potential in this part of the circuit, and that is why you are getting the deflection of the galvanometer as 0. That means from the question, we can get the idea that there is a 2 volt of the potential difference between this branch. Now, if there is a 2 volt of the potential difference between this branch and there is another battery of the 12 volt, which both are again connected to each other by positive terminal to positive terminal. So now your total EMF will become E1 minus E2 and 12 minus 2. Therefore, your EMF becomes a 10 volt. So now if you are getting that the EMF is equals to 10 volt, you can simply apply that V is equals to IR Ohm's law for this particular branch, because this branch is getting the voltage of the 10 volt. And now how do you find the current through that branch, which is V is equals to IR. We have derived the potential, which is 10 is equals to I into resistance is given as a 500. So you can say current will be equals to 10 upon 500 ampere. Now because we have got the current through this resistor, we can say current through this resistor will also be same. Now what is the reason for that? It is very simple. Both are connected in series with each other. If both are connected in series with each other, we can take the same current through this resistor. But what about the voltage? We have already got the voltage. Between these 2 points, the voltage will be 2 volt. Then only you will be getting the zero current at this branch. So again apply the V is equals to IR rule for this particular branch. So now voltage in this branch is a 2 volt, which is equals to current is same as of this resistor, because both are connected in series. So it becomes a 10 divided by 500 into resistance R. And that is what you need to find, the value of the R. Simply make this a subject. So R becomes 800 into 2 divided by 10. And you will get the answer of this question as 100 ohm. Okay, this is a 500. There is a slight mistake just due to this. Okay, so the value of this is 500. So you will get the answer 500 into 2. 500 into 2, which becomes 1000. And this 10 will go in the denominator, 0 0 cancel, and now your answer you can say will be 100 ohm. Okay, let us move to the next question. Okay, so next question is as following figure. 2 ampere current is passing through a conducting wire. Radius of the cross sectional of the wire at point A is a 3r and point B is r respectively. Then find the ratio of the drift velocity at point A and point B. Now to find this, you need to remember the relation between the drift velocity and the current, which is given in the chapter number 3 standard 12. And you guys are aware that the relation between them is I is equals to NEAVD, where Vd is the drift velocity. Now value of the current is given, which is a 2 ampere. So we can say current of 2 ampere is passing from this cross sectional area, as well the current of 2 ampere is passing from this cross sectional area. And if the same current is passing through the both the cross sectional area, we can say even if the area is changing, current is remaining constant. So if this current is constant, we can say constant is equals to A into Vd. Why I have written it only A and Vd? Because N and E are already constant. So we can, by this equation, we can say Vd will be equal to constant divided by area. Now if you remove the constant and the equal sign, you can say velocity, drift velocity is inversely proportional with the area. And what are they asking? They are asking you to find the ratio of the drift velocity of point A and B. So I can say drift velocity at point A divided by drift velocity of point B will be equals to the area at B divided by area at A. So VA upon VP becomes, this is the R. So it will become the area of this becomes pi R square. But I am not writing the pi because pi will be cancelled out here. So only R square divided by pi into R square. But for this the area is 3R. So the square of 3R will be 9 into R square. R square cancels out each other, and now your answer becomes 1 divided by 9. which is given in the second option, which is your correct answer. Okay, let us move to the next question. In a potentiometer arrangement, it is a question from the potentiometer chapter 3 standard 12. A cell of the EMF 1.5 volt gives a balance point at a 150 meter length of the wire. If the cell is replaced by the another cell and the balance point is shifted to the 210 centimeter, what is the EMF of the second cell? Now for the potentiometer, you should be knowing the equation that E1 divided by E2 is equals to L1 divided by L2. Now there is a, let me give you a brief idea about the potentiometer so that you can get the revision of the potentiometer as well. We will be solving this equation thereafter. So in the potentiometer, there should be one battery, one resistor, and the upper circuit, what do we call, and there is a one wire connected with it, and you are getting zero deflection at some point in this potentiometer. So at the zero deflection, what happens is the EMF of this and EMF of the lower battery becomes equal, and you can find the EMF of this one by the potential gradient. What is potential gradient? It is voltage per unit length. How do you find the voltage per unit length? EMF of this one will be given. V is equals to IR, and you will get the voltage per unit length. Length will also be given in the question if they are asking such type of the question. Right now, you don't need the potential gradient. We are just discussing the theory of the potentiometer. Okay, so by this you can take the idea of the potentiometer, and further by doing the further derivation, there is a relation of the potentiometer which is E1 upon E2, which is equals to L1 upon L2. Now the values of the E1 is given, which is a 1.5 divided by E2. The length of the first time, which is a 150 centimeter, divided by second, it is a 210 centimeter. Just solve the equation, get the value of the E2. Very simple type of the question. So E2 is equals to 1.5 into 210 divided by 150. And by doing this in the calculator, you will get the answer of the potentiometer, which will be equal to the 2.1 voltage. First option, which is your correct answer. Let us move to the next question. Circular loop having a radius R carrying current I produces the magnetic field at the center of the loop is a B. What will be the magnetic dipole moment of this loop? Now you all are very well aware about the formula of the magnetic dipole moment. There are two kinds of the different magnetic dipole we have discussed. So if you have a conducting loop and current is passing through this conducting loop, you can say the formula of the magnetic dipole moment M is equals to NIA, where N is a number of turns, I is a current passing through the loop, and A is the area of the loop. But what happens if they have given you the magnet and if you want to find the magnetic dipole moment? So for in case of the magnet, we can say there is a length of the magnet is L. There is one north pole and south pole. So in this case, the magnetic dipole moment becomes the pole strength into the length of the magnet. If you have written this in the school that the magnetic dipole is equals to M into 2L, just don't get confused. It is possible that in your school, your faculty has taken the length of the magnet as a 2L. That is why you have taken here the 2. That is not a big deal. The only formula is to the product of the pole strength into the length of the magnet. We have taken the length of the magnet as L. That is why I am multiplying L with the pole strength. Okay, let us talk about this question. So in this question, they are not asking you anything about the magnet. We have just revised the theory, full theory of the magnetic dipole moment. Here in this question, they are asking you about a circular loop. So we do have one circular loop and current is passing through this, and you want to find the magnetic dipole moment at the center. So for the magnetic dipole moment, we have an equation NIA as we have just discussed. And what is the number of turns for this? Number of turns is 1. So you will get that magnetic dipole moment is equals to current into area. Now how will you get the equation of the current or the value of the current? Because as you can observe in the options, there is no current in the formula. So what they have done, they have converted the current in the form of the magnetic field. How will you do it? You need to know what will be the magnetic field at the center of the loop. That formula is given in the 4th chapter standard number 12. What will be the magnetic field? The magnetic field will be equals to mu naught I divided by 2R. Make a subject a current. So current I will be B into 2R divided by mu naught. Place the value of the current in this equation. So dipole moment becomes B into 2R divided by mu naught, and A is the area of the loop. Anything given about the area? No. So let us consider the radius is R, and therefore the area will be pi into R square, and this R and this R is same only. So let me write this one also a capital R. So it becomes pi into R square. So now our magnetic dipole moment will become 2 pi into B R cube divided by mu naught. This is the formula of the magnetic dipole moment. Let us match the option 2 pi B R cube divided by mu naught. Yes, it is given in the third option, which is your correct answer. Okay, let us move to the next question. The horizontal component of the Earth's magnetic field at a certain place is 3 into 10 raised to minus 5 Tesla. And the direction of the field is from the geographic south to the geographic north. A very long straight conductor is carrying a steady current of the 2 ampere. What is the force per unit length? This is the important term. They are asking a force per unit length or not, and not asking only the force. Okay, force per unit length on it when it is placed in a horizontal table and the direction of the current is east to west. So basically, you can say that they have placed the current carrying conductor in such a way that it is a perpendicular to the applied magnetic field. So there is a magnetic field in south to north, geographic south to geographic north, which we all are very well aware about the earth magnetism. And then there is a current carrying conductor from which current is passing from east to west, or east to west, not west to east. So current is passing from east to west. So this is a current carrying conductor placed in a uniform magnetic field perpendicular to it. So what is the formula to find the force? F is equals to IBL. Where you have studied this? You have studied this in the chapter number 4, standard 12. After the Lorentz force, there is a derivation of this equation in your textbook on the left hand side of the page. Now, again in this equation, they are not asking you the force. I have said it first only. They are asking you force per unit length. So length goes on that side, and force per unit length becomes I into B. Now, what is the value of current? It is 2 ampere. Into what is the value of the magnetic field? It is 3 into 10 raised to minus 5 Tesla. So your answer 2 into 3 becomes a 6 into 10 raised to minus 5. 6 into 10 raised to minus 5 is given in the second option, which becomes your correct answer. Yes, one more thing, students. Let me tell you one very good thing about the paper. Whenever you are getting this type of the long question, just do one thing. Whenever you are getting the values, just make an underline or a square of that value. Because after putting the equation, if you have not done, or if you have not highlighted these values, you will be finding it in the question. And maybe you need to find these values again, and in order to that, you need to read the question again, which consumes the time. And you all are aware that time is very much important in the competitive exams, right? Okay, so let us move to the next question. For this one, your answer is second, which is 6 into 10 raised to minus 5 Newton per meter. Okay, so the next question says a solenoid of the length 0.5 meter has a radius of the 1 centimeter. Length is given as a 0.5 meter. Radius is given as a 1 centimeter. Is made up of the 1000 turns. Total turns are given. It carries a current of the 10 ampere. What is the magnitude of the magnetic field inside the solenoid? There is a formula for the magnetic field inside the solenoid. What is the formula? If you have a solenoid and current I is passing through the solenoid, you can say the formula of the magnetic field inside the solenoid, which is a uniform magnetic field, and formula for that is a B is equals to mu naught into small n into I. Now, what is a small n? So small n is a total number of turns divided by length of the solenoid into current I. Take the formula here. B is equals to mu naught into total number of turns into current divided by length of the solenoid. What is mu naught? Permeability of the free space. What is the value of that? 4 pi into 10 raised to minus 7. What is the total number of turns? Radius of 1 centimeter made of the 1000 turns. So it will be 1000 into what is the value of current? It is 10 ampere. Divide by what is the length of solenoid? 0.5. And for the 0.5, I can write 1 divided by 2. And this 2 will go up on the numerator again. So there is nothing to divide. just need to use the calculator, multiply these values, and you will get the answer 2.51 into 10 raised to minus 2 Tesla. Okay. So the next question. Yes, at a certain place on the surface of the earth, horizontal component of the earth's magnetic field is same as a vertical component. What are they giving? It is the same as a horizontal and the vertical of the earth. Then what will be the angle of dip at that place? Now to find the angle of dip, you must need to remember the theory. There is a theory of the earth's magnetism in the chapter number 5, standard 12. What is earth's magnetism? There is a geographic north pole and geographic south pole. But where is the geographic north pole? At that place we have a magnetic south pole of the earth, which is slightly shifted from the north pole. So we can say at here somewhere there is a magnetic south pole, and at here somewhere there is a magnetic north pole. And this is something how we have a magnetic field of the earth. And in this magnetic field, at any certain point, tangent gives the direction of the magnetic field, and this magnetic field is making some angle with the horizontal, and this angle, by this angle we can say this is a horizontal magnetic field and this one is a vertical magnetic field. What they are saying? They are saying that the horizontal magnetic field and the vertical magnetic field both are same at some place. So for that, what can I write for the horizontal magnetic field? By taking the component of the total magnetic field, can I say it is a B cos theta is equals to BH? I'm sorry. Yes. B cos theta will be equals to BH and B sin theta will be equals to BV. This is a simple rule of the vectors, that your vector is making theta with whichever the surface will become the cos component of that particular vector, and perpendicular to the cos component you will get the sine component. So for the BH horizontal magnetic field, I can say it is equals to the B cos theta, and for the vertical magnetic field I can say it is equals to the B sin theta. Now it is given in the question that horizontal magnetic field and vertical magnetic field both are equal to each other. So for that I can say B cos theta will be equals to B sin theta. This B cancels out each other. Take the cos on the another side in the denominator of the sin theta. So it becomes a sin theta divided by cos theta is equals to 1, which gives us the value tan theta is equals to 1. And what is the value of the theta for what tan is equals to 1? So tan 45 is equals to 1. So what is the angle theta? The theta becomes a 45. And also you don't need to solve this much in this question, because it is a simple law of the vector that if there are two vectors perpendicular to each other of the same value, the resultant vector will be at a 45 degree. This is a simple rule of the vector which you have studied in the standard 11 chapter number 4. And also if two vectors are equal and perpendicular to each other, what will be the value of the resultant vector? This is only the theta of the resultant vector. What if they ask you the value? They could ask this, and the value will become the root 2 times of the B. Let us say the value of this is also B and this is also B. Then the resultant will become root 2 times of B. Okay. So let us move to the next question. Okay. What is the magnitude of the equatorial field? Sorry. Due to bar magnet of the length 5 centimeter at a distance 75 from its midpoint, and the magnetic moment of the dipole moment is 0.75. If you do have a magnet, we have just discussed it for the electric field, and there is a synchronicity between the electrostatic and magnetostatic. So we have discussed it just before the few minutes in the other question, that if you have a dipole moment, then for that dipole moment on the point of the axis, the electric field will be 2 kp divided by r cube for axis, and for the equator this will be equal to kp divided by r cube. And as I have said, there is a synchronicity between the electrostatic and magnetostatic, and definitely you have discussed this in your school. So what it becomes, 2 remains, 2k is the constant of electrostatic, and constant of the magnetostatic is mu naught divided by 4 pi. This is electric dipole, place a magnetic dipole in place of that, and r cube is a distance which remains as it is. And also for this formula, k is a constant of the electrostatic, replace it by the constant of the magnetostatic. P is a electric dipole, M is a magnetic dipole moment, and the R remains as it is. In this question, they are asking about the equatorial point. So for the equatorial point, the formula becomes mu naught upon 4 pi into M divided by R cube. Mu naught is 4 pi into 10 raised to minus 7. 4 pi cancels out each other. So in place of this term, I am simply placing 10 raised to minus 7 into the dipole moment. It is given as a 0.75 divided by R cube. What is the distance? Yes, 5 centimeter. Cube of 5. So it will become 5 into 5 into 5 into 10 raised to minus 6. Because you need to convert this 5 centimeter into the meter. And for the one time it will be 10 raised to minus 2, and for 3 times it will be 10 raised to minus 2 3 times, so it becomes 10 raised to minus 6. Again, I have placed the values for you. Just use the calculator, place the all the values in the calculator, and you will get the answer. And this answer will be equal to 1.78 into 10 raised to minus 7 of Tesla. Okay, let us move to the next question then. For a long current carrying solenoid having inside magnetic field is 0.6, then find the magnetic energy. Then find the magnetic, then find the magnetic energy per unit volume. Now, what is the formula to find the magnetic energy per unit volume? It is simply B square divided by 2 into mu naught. And also there is a formula of the electric energy per unit volume. What is the formula for that? It is 1/2 into epsilon into E square. You have studied this formula into chapter number 2. Okay, now simply place the values in this equation. Magnetic field is given, so it becomes 0.6 into 0.6 divided by 2 into mu naught, which is 4 pi into 10 raised to minus 7. Very easy type of the question. You just need to remember the formula, and if you know the formula, just place the values, use your calculator very well, and you can get the answer. And the answer for this question will be 1.43 into 10 raised to 5. Okay, move to the next question. The self-inductance L of a solenoid of length L. Self-inductance, they are talking about the self-inductance, and area of the cross-section A increases. Now, how can you say that the self-inductance is increasing? With respect to the length and area. So, for that you need to remember the formula of the self-inductance of the solenoid. What is the formula of self-inductance of solenoid? So, it is L is equals to mu naught into N square into area divided by L. So how can you increase the self-inductance? This L is about the length of solenoid. Let me write the small s so you don't get confused. This is the length of solenoid and this is a self-inductance L. Okay. Now how can you increase the self-inductance of the solenoid with respect to area and length? So as you can clearly see from the formula, area is directly proportional. So you need to increase the area, and length of the solenoid is inversely proportional. So you need to decrease the length of the solenoid. So you can say whenever the L decreases and A increases, yes, it is given in the second option. So second option becomes your correct answer. So next question says a pair of the adjacent coil has a mutual inductance of a 1.5 Henry. Mutual inductance is given. If the current in the one coil changes from 0 to 20 in 0.5 seconds, change of the current is given from which is changing from 0 to 20 in 0.5 seconds. What is the change in flux linkage with? Change in flux they are asking with the other coil. How will you get the change in flux? The formula of flux is very simple. It is mu into I. How you are getting this formula? Because flux in the second coil will be directly proportional to the current from the first coil. What is the theory of this thing? There are the two coils. One is connected with the source, another is as it is, just a closed circuit. If you will increase the current through the first one, this flux of this first will be connected to the second one, and due to that this second will experience the changing magnetic field, and so there will be some EMF. And how much amount of the change of flux this will experience? The change of flux in this will be equal to current in this. So therefore we can say flux is equals to M into I. Remove this sign of the proportionality, put the equal, and there is a constant capital M which denotes the mutual inductance. So now what the values they are given, I can say delta flux is equals to M into delta I. What we need to find, change of flux is what they are asking. What is the mutual inductance? The mutual inductance is given as a 1.5 into change in current. What is change in current from 0 to 20? So you can say it is 15 into 2, which is equals to 30 Weber. So 30 Weber, which is given in the second option, that becomes your correct answer. Okay, so the next question says a 50 mu F microfarad capacitor is connected to a 110 volt and 60 hertz AC supply. Determine the RMS value of the current in the circuit. So you can get the value of the RMS value by the simple formula. Even if you know the formula of the Ohm's law, which is V is equals to IR, you can say I RMS is equals to V RMS divided by resistance. But because they have connected here a capacitor, there will be some resistance due to the capacitor in pure capacitive circuit, and that resistance is called as a capacitive reactance. And what is the formula of the capacitive reactance? So the capacitive reactance XC is denoted by 1 upon omega C. There is also the resistance by the pure inductive circuit, which is called as a inductive reactance. How do we denote it? We denote it by the XL. What is the formula of the XL? The formula of the XL is equals to omega into L, and there is some resistance due to the pure resistive circuit also. What is the formula for that? It is simply resistance. V is equals to IR. Okay, so right now we have a capacitive circuit. So here instead of the R we can say it is XC. What are they asking? They are asking, okay, there must be VRMS value. VRMS value will be equal to the IRMS into RXC. Now they are asking us the value of the IRMS. So IRMS will be equals to VRMS divided by 1 upon omega C. Now this omega C will go into the numerator, and therefore IRMS value will be VRMS into omega. Do they given the value of the omega? No, they have given the frequency. So what is the formula of omega? Omega is 2 pi by T, and instead of 1 upon T you can write F. So formula of omega becomes a 2 pi F. So here instead of the omega we can write it is a 2 pi F into capacitance. So the formula becomes a VRMS. What is the value of VRMS? 110. Remember one thing, if they haven't clarified that whether this value is a VRMS or the V average or the V at instantaneous time, you need to take it, or you need to consider it as a RMS value. If they haven't clarified, the value is RMS, that is for fixed in all the questions. Okay, so VRMS is given as a 110 into 2 into 3.14 into frequency 60 hertz into capacitance, which is 50 into 10 raised to minus 6. Just let me clear the board a little bit. Yes, so we have placed the value of 2 into pi into frequency, and the value of the C is given as a 50 into 10 raised to minus 6. Just solve this in the calculator, and by solving this you will get the answer as a 2.1 ampere. Again, we have discussed the theory, we have discussed the equations, we have put the values in the equation. Just do the calculator part and you will get the answer of the 2.1 ampere. Okay, so let us move to the next question. Okay, so the next question says for LCR AC circuit, L is equals to 25 millihenry, resistance is equals to 3 ohm, and capacitance is equals to 62.5 microfarad. What is the frequency of the source at which the resonance occurs? At which the resonance occurs means what? It is a resonant frequency. The question is of the resonant frequency. Now there is an angular frequency also. What is the formula of the angular frequency? The formula of the angular frequency is 1 upon under root LC. Let me write it for you. Omega will be equal to 1 upon under root of the LC. Now what is the value of omega? We have just taken it into the previous question, that omega is equals to 2 pi by T, which is equals to 2 pi F. So place the value of omega, which is equals to 2 pi f is equals to 1 upon under root LC, and then your frequency becomes 1 upon 2 pi into under root of the LC. So there are two important formulas. One is of the angular frequency and another is of the resonant frequency. From both the equations, questions could be asked and you need to remember this both. Right now our question is about the resonant frequency. So let us take the formula of f, which is equals to 1 upon 2 pi into under root of the LC, which is equals to 1 upon 2 into 3.14 under root. What is the value of L? It is a 25 into 10 raised to minus 3 into capacitance C, which is given is a 62.5 into 10 raised to minus 6. Just put the values in the calculator, get the answer. And if in case you are getting confused that how will you get the root of the 10 raised to minus 9, just replace one point on the left side, it will be 10 raised to minus 8. And after getting the value 10 raised to minus 8, you can get the root of that, which is 10 raised to minus 4. That 10 raised to minus 4 will go on the numerator, and then you will be solving this equation in the calculator. What happened? Audio on check? Audio નથી on? Audio on છે? ઓકે ઓકે. તો બેટરી જરાક ચેન્જ કરી નાખો. બેટરીનું જ છે ને? હા, તો ખાલી ચેન્જ કરી નાખો. થોડુંક સ્પીડમાં બોલાવજો આશીષભાઈને, છોકરાઓની કનેક્ટિવિટી ન તૂટી જાય. આશીષભાઈ તમે ક્યાં વયા જાવ છો? તમે અહીંયા રહ્યો સરજી. બેટરી ગઈ છે, જલ્દીથી ચેન્જ કરી નાખો જરાક. કાંઈ ખબર નહીં બંધ છે ચાલુ ચાલુ છે, બંધ કરી દો. પછી પાછું કનેક્ટ નહીં કરવું પડે, પછી કનેક્ટ નહીં કરવું પડે પાછું. ઓમાં નથી આવતો વિડીયો. બેક ઓડિયો આ તો કનેક્ટ છે ને? આ જોઈજો તો આમાં ઓડિયો આવે છે ને? Okay students, so there was some technical error. I think the battery of the camera was dull. Okay, so we are back again. So you just need to place the values, and if you are getting confused that there will be 10 raised to minus 9 and how will you get the root of the 10 raised to minus 9, just place the point one time in the left direction and you will get it as a 10 raised to minus 8, and the root of the 10 raised to minus 8 will be 10 raised to minus 4. It will go into the numerator and becomes the 10 raised to plus 4. Then you can easily calculate this term, and then answer will be the 127.39 of the hertz. Okay. So let us move to the next question. For a series LCR circuit with L is equals to 2H, C is equals to 18 and R is equals to 10, what is the value of the Q factor? What is the formula of the Q factor? So the formula of Q factor is 1 upon R into under root L divided by C. All the values of R, L, C are simply given in the question. You need to just place the values, use the calculator and get the answer. Let me put the values for you. 1 upon resistance. Resistance is 10 ohm under root L. What is the value of L? It is 2 Henry divided by capacitance. It becomes 18 into 10 raised to minus 6. This 10 raised to minus 6 will come out of the root as a 10 raised to minus 3 and go in the numerator as a 10 raised to plus 3. Will be equal to 10 raised to plus 3 divided by 10 under root of 2 divided by 18. 2 divided by 18 is nothing but 1 upon 9. No further calculation is needed for me to done. You can easily do this and the answer will be 33.33, which is given in the first option. Okay, so the next question says that what is the range of the radio frequency band of the FM frequency? So they are asking you the range of the radio frequency band of the FM. What is the range? It is a purely database question that your answer will be 88 megahertz to 108 megahertz. It is given in the chapter number 8, standard 12, page number, I think it is 281 page number, and from the topmost the line is a 6th or 7th line. Oh, okay. This is again the value 54 to 89. It is the value of the TV. Value for the TV. 533. It is a value of the AM. All the values are given simultaneously in the textbook. I think it is in the 7th line. This one will be in the 6th line, and this one will be in the 5th line in the page number of the 281. Simply database question. We don't need to discuss it further. So let us move to the next question quickly. A plane of the electromagnetic wave of the frequency is a 25 megahertz. So the frequency is given 25 megahertz. Travels in the free space along the x direction at a particular point in the space. Then magnetic field is given and find the electric field at that point. What is the relation between electric field and magnetic field? So electric field divided by magnetic field will be equals to C. This formula is given in the chapter number 8, standard 12. There is one another formula which is related to the C, which is equals to C is equals to 1 upon under root epsilon naught into mu naught. In case if they ask the question from this, right now we don't need this in this question. So for this question, the value of the B is given. So E is equals to value of B, that is 2.1 into 10 raised to minus 8 into the value of C. What is the value of C? It is 3 into 10 raised to 8. So simply 2 into 3 will be 6. The answer is around 6. Yes, there is one answer, 6.3. Simply 2.1 into 3 is nothing but 6.3 only. And 10 raised to minus 8 and 10 raised to plus 8 cancels out each other. In this question, you don't need to simplify even. Only you need to remember this simple formula which has only 3 terms, the shortest formula. And also the simplification is very easy. In a simple Gujarati, I can say ladu kevai ladu our question. Okay, so the answer is 6.3. And also there are no other directions are given. They have given only one direction and one correct answer in the 6.3. But if you need to find the direction, how will you get it? So you all know that in the electromagnetic wave, there will be electric field and magnetic field perpendicular to each other. And by getting the E cross B, you will get the direction of the propagation of the wave. And right now they are asking you that the direction of the electric field. Right now they are not asking it. The options are very easy, so you can get easily. But in case if you need to find the direction, how will you get it? That the E cross B will give you the direction of the propagation. So cross product of the any two vector will give you the direction of the third one, because all the three are perpendicular to each other. So right now you have a direction of the magnetic field into the K cap. And also you have another direction which is in the positive x direction. It is given the propagation direction is positive x. So positive x is I cap cross K cap, which will give you simply J cap. If you cross product the two vectors, the answer will be in the direction of the third one. So here it is given in the J cap also. So it is a 6.3 J V by M. Okay. So let us see the next question, which says that glass prism having a refractive index mu placed in a air for that angle of minimum deviation of the prism is as same as the angle of prism. Angle of deviation is the same as angle of prism. And what is the value of the angle of the prism? What is the formula for that? Mu is equals to, if you are writing mu or n, that all things are same only. So mu is equals to, what is the formula for this? Sine into a plus d divided by 2 divided by sine of a divided by 2, where a is the angle of prism and d is the angle of deviation. And in the question they are saying that the deviation is same as the angle of prism, and your answer is in the term of the angle of prism. So instead of d, because a is equals to d, it is given in the question, instead of d I can write a. So this term becomes mu is equals to sine a plus a divided by 2, which becomes 2 times a by 2, and in the denominator there will be sine a by 2 term. So now you need to simplify this. How will you simplify this? So there is a formula of the trigonometry that sine 2 theta will be equals to 2 times sine theta into cos theta. So according to this formula, you can write this term as mu is equals to 2 times sine a by 2 into cos a by 2 divided by sine of a by 2. This sine a by 2, sine a by 2 cancels out each other, and you remain with a mu is equals to 2 times of cos a by 2. Now it will be 2 times of the cos inverse mu by 2 by further simplifying this equation, which is clearly visible from here, which is given in your option number 4. Okay. So the next question says the radii of curvature of the faces of a double convex lens. Faces of a double convex lens are 10 centimeter and 15 centimeter. Its focal length is a 12 centimeter, and what is the refractive index of the material? So you need the formula which correlates the focal length as well the refractive index and as well the radius of the curvature. So you all are very well aware what is the formula. The formula is 1 upon f is equals to mu L minus 1 into bracket 1 upon R1 minus 1 upon R2. So will you take 10 and 15 as it is? No, you cannot take it. Why? Because you have a double convex lens, and for the double convex lens, one radius of curvature should be taken as a negative as it is in the left direction, and other should be taken as a positive as it is in the right direction. So the one value will be plus 10, another value will be minus 15. Now you can place the value that 1 upon 10 minus 1 upon minus 15. So it becomes minus minus plus 15. Value of the focal length which is given into the question. Where is the value of focal length? Yes, it is a 12 centimeter. So 1 upon 12 will be equal to mu L minus 1 into bracket 1 upon 10 plus 1 upon 15. So it becomes a 3 plus 2 divided by 30. So it becomes 5 by 30, and 5 by 30 becomes a 6. And now this 6 cancels out with the 2. So the equation becomes 1 by 2 is equals to mu L minus 1. Now you just need to solve this equation, and the answer of this will be 1.5, which is given in the second option. Okay, let us move to the next question then. So the next question says that find the equivalent focal length due to the combination of the two convex lens. Combination of the two convex lens are in contact having a focal length, both of them is 30. Both of them is 30. How will you get it? So for this, for the combination, you have a formula 1 upon f is equals to 1 upon f1 plus 1 upon f2, and because it is a convex length, and for both the convex length, focal length will be positive only. So yeah, you just need to place the value which is equals to 1 upon 30 plus 1 upon 30. It is clearly visible. 2 upon 30 will be 1 upon 15, and by get the reciprocal, you will get the answer as a 15 centimeter, which is given in the fourth option. Okay, so the next question says a tank is filled with the water to a height of the 16 centimeter. Find the apparent depth of the needle lying at the bottom of the tank is measured by a microscope. Refractive index is given. So how will you find the apparent length? So the formula for the apparent length is equals to apparent height. Apparent height is equals to actual height divided by the refractive index. Now whether you are writing refractive index as a n or eta or mu or whatever it is, but right now in the question it is given as a mu omega, mu w for water. So the height actual is given in the question. Yes, it is a 16 centimeter. So it is 16 divided by mu w is given. 4 divided by 3 goes in the numerator. 4 4s are 16 and 4 3s are 12. So answer becomes the third option, which is a 12 centimeter. Very easy question. Okay. Next question. Estimate the distance for which the ray optics is a good approximation. Okay, good approximation we have entered in the Fresnel for an aperture of the 5 millimeter and the wavelength of the 500 nanometer. So for the good approximation, we have a very short formula that good approximation is equals to a square divided by lambda. Where what is A is aperture, what is lambda? It is a very obvious thing, it is a wavelength. And what is the length of aperture is given? It is a 5 millimeter. So you can say 5 into 10 raised to minus 3 whole square divided by the wavelength, which is given 500 nanometer. So you can say it is 500 into 10 raised to minus 9. Very simple formula, very simple values. I think you don't need to also use the calculator in this case, and your answer will be 50 meter, which is given in the second option. So let us move to the next question. The wavelength of the light 500 nanometer is used in a young double slit experiment. Lambda is given. For the young double slit experiment, the distance between the slit and the screen, distance between slit and the screen, that means the capital D is given. And the slits are separated by 1 millimeter. Distance between the two slits, that means the small d is given. Then find the distance between the fifth and the third bright fringes. So you all know for the fifth bright fringes, you can say 5 times lambda is equals to distance of the fifth into small d divided by capital D. So this x5 distance of the fifth will become 5 lambda d divided by d. And in the same way for the third, just you will write here a 3 lambda and x of 3. So your value for the third one becomes a 3 lambda d divided by small d. And now they are asking you the distance between these two. So distance between those two will be lambda 5 times d divided by small d minus of 3 lambda capital D divided by small d, which leads us to the value 2 lambda d upon d. All the values are given in the question. It will be 2 into lambda, which is 500 into 10 raised to minus 9, because it is given in the nanometer. Then capital D, value of the capital D is 100. I am not writing into 10 raised to minus 2, because also in the denominator there is a small d which is given, that is given in the millimeter. So we need to write it 10 raised to minus 2. And in case of the millimeter, 1 into 10 raised to minus 3. Again, you have the formula. I have placed the values for you. Just use the calculator, and by solving this question, by solving these numbers, I will not say solving the question because I have solved the question for you. By solving this number in the calculator, you will get the answer in this question, which is a fourth number, 1 millimeter, which is your correct answer. Okay. So now let us move to the next question, and we are only remaining with the last of the 4 questions. Okay, so which of those metal having the least work function? Again, a database question, and we cannot discuss, or we should not discuss anything about the database question, because the table is simply given into the NCERT, and the least work function is because of the Na, which is given in the first option. There is no other option. You just need to memorize this thing in order to get these marks. Okay, so let us move to the next question. What is the de Broglie wavelength associated with an electron accelerated through a potential difference of the 64 volt? So they are asking it for the de Broglie, and the formula for that becomes lambda is equals to 12.27 divided by under root of the potential, and the potential's value is given in the question, which is 64. So it becomes 12.27 divided by 8. Just solve this question. As you can clearly visible, the answer will be between 1 and 2, and because it is in the order of the 8, the answer will be exactly between 1 and 2. It will be around 1.5. Yeah, second option is given, which is 1.5 angstrom, which becomes your correct answer. And by passing this question, I can say now we remains with the only last 2 questions. So stay tuned. We are only remaining with the 2 questions only. Okay. in the photoelectric effect that the graph of the stopping potential V naught versus the frequency V is a straight line, what will be the slope of this straight line? You all know the equation for this, which is EV naught, which is equals to HF minus phi. Now the graph is of the potential V naught and versus the frequency versus the V naught. And if you want to equate this equation with the equation of the straight line, which is y is equals to mx plus c, so you need to get this term out from here, then only you can equate this with the y is equals to mx plus c. So let us divide this equation by the e, and it becomes v naught, which is equals to h divided by e into f minus phi divided by e. Now we have the equation of the straight line, which is y is equals to mx plus c. So it becomes y is equals to mx plus c. If they ask you the intercept, then this will become your intercept. Right now they are not asking it, we are just discussing in case if they ask you in the next paper. And what is the slope? M is the slope, which is a coefficient of the x, and coefficient of the x is h d naught divided by e. So now your answer for the slope becomes h divided by e, which is given in the second option. Okay, let us move to the next question, and which I think becomes our last question. Yes, it is our last question. Okay, so what is the shortest wavelength present in the Balmer series? Balmer series, do you remember the number? Lyman, Paschen, Balmer bracket, Lyman, Paschen, Balmer, Lyman, Balmer, Paschen bracket. Yes, that is how it is. So Balmer is for the second one. And R is a Rydberg constant. We very well know that they are asking it. Yes, they are asking it for the shortest wavelength. And for the shortest wavelength, we need to go to the infinite, because only at the infinite, the energy, only to reach the infinite, the energy will be maximum. And if the energy is maximum, lambda will be minimum, because energy and wavelength both are inversely proportional to each other. So if they are asking you for the shortest wavelength, you need to go to the infinite distance. Now let us talk about the formula, which is equals to 1 upon lambda is equals to r 1 upon, what is it? Yes, it is a Balmer, Lyman, Balmer, Paschen bracket. Balmer is the second one, square of 2, that is 4, minus 1 divided by square of the infinite, because as they are asking for the shorter wavelength. So now your question, your answer becomes 1 upon lambda is equals to r by 4. And because they are asking you the lambda, so lambda becomes a 4 divided by r. Even they haven't asked you to solve this by placing the value of the r. What happened? Is audio on or not? Video is also on? Okay. Okay. They are not even asking you to solve this by placing the value of the r, which is a Rydberg constant. Now, what is the value of the Rydberg constant? Although they are not asking it right now, but in case in the next paper, if you need to place the value of the Rydberg constant, you should be remembering it. What is the Rydberg constant? It is 1.09737 m inverse. This is the value of the Rydberg constant. But right now you don't need to. Okay, here it will be into 10 raised to 7. But here you don't need to place the value of the Rydberg constant. Simply your answer becomes a 4 divided by r, which is given in the first option. So, okay guys, we have done with the GUJCET paper of the 2021, and I must say that we have not only done with the paper and the solution, we have also go through the so many theories, and I think you have revised your many of the theories, which will help you in the upcoming GUJCET paper, which is just after the 2 days. So stay tuned for the 2 minutes. We will be also discussing the next paper, which is a 2022 GUJCET paper. Stay tuned for the few minutes. I will be back in 8 to 10 minutes. Thank you very much. ऑडियो स्टॉप कर दे। હવે audio આવી ગયો ને? Okay. Hello students, welcome again, and here we are back again with the paper of the 2022 GUJCET. We have discussed the paper in detail of the 2021 GUJCET. So now, without wasting your much time, let us start with the first question of the 2022 GUJCET paper. How the shunt wire should be? How the shunt wire should be? The shunt wire should be of the low resistance, and because you need to find about the relation of the length and thin and thick, that means they are asking you the relation of the area. So you need to know how the resistance is connected with the length and the area. So we have a formula of the resistance. R is equals to rho L divided by A. So by this formula you can say that resistance is directly proportional to the length and resistance is inversely proportional with the area. So if you are having a shunt wire, so the shunt wire should be having a low resistance, and for that low resistance we can say length should be small. Length should be small because you need a small r, and because you need a small r, area should be higher. So length should be small and area should be higher. So if length should be small, we can say short are the options which are remaining. Options which are having a long length are not the correct answer. And area, we need the more area, that means we need the thick wire, and here it is given in the thick. So the answer number 4, which is short and thick, which is your correct answer. Okay, let us move to the next question. You have seen that formula of the resistance in the chapter number 3, standard number 12. Okay, so the next question says, two long and parallel straight wires A and B, long and straight parallel wires. By this only you should be getting the strike in your mind about the formula. Carrying the current of the 10 ampere and 4 ampere in the same direction and separated by the distance of the 2 centimeter. Distance between the two parallel wires is 2 centimeter. Estimate the force on a 4 centimeter of the section. Now, in this question, the mistake might be happened by you, which is a very small, because you might be remembering, you might be memorizing the formula of the force is equals to mu naught into I1 into I2 divided by 2 pi r. But my friend, this is not the formula of the force. This is a formula of the force per unit length. And right now they are not asking you the force per unit length. They are asking the force on a 4 centimeter section. So you need to multiply this length on the other side. So that now the formula of the force becomes mu naught into I1 into I2 into length divided by 2 pi r, where r is a separation distance between the two wires. You have the formula force is equals to mu naught, which is 4 pi into 10 raised to minus of 7 into I1. Values of the current are given 10 and 4. I1 into I2 into length. Length is at 4 centimeter, so it becomes 4 into 10 raised to minus 2 divided by 2 into pi. Clearly pi cancel out, and r, which is a separation distance, which is 2 into 10 raised to minus 2. 10 raised to minus 2 cancels out each other. Just put the values in the calculator, get the answer, and your answer will be 1.6 into 10 raised to minus 5 of the Newton, which is given in the second option. Quickly move to the next question, which says a solenoid has a core of a material with a relative permeability. The relative permeability is given. What is relative permeability? Mu r, which is given as a 400 unit. The windings of the solenoid are insulated from the core and carry a current of the 1 ampere. Value of current is given. If the number of the turns N is given 1000 per meter, okay, 1000 per meter, that means it is not a value of the capital N, it is a value of the small n. What is the small n? It is a number of turns per unit length. So the value of the small n becomes 1000. Okay, and find the magnetic field. You need to find the magnetic field, and the formula for the solenoid is equals to mu naught into total turns into current divided by length of the solenoid. What is the value of the mu naught? Okay, here we shouldn't use the value of the mu naught, as there is some other material at the core of the solenoid. You should be using the permeability of that particular material. And how do you get the permeability of that particular material? We have the formula for that mu r is equals to permeability of the material divided by mu naught. So formula of the mu becomes mu r into mu naught. So here instead of the mu, I should write mu r into mu naught into n divided by length of the solenoid into current. So now relative permeability is given in the question, which is 400. You should be remembering the value of the mu naught, which is 4 pi into 10 raised to minus 7. N upon Ls combinedly can be written as a small n, and value of the small n is given, which is a 1000 into the value of the current, which is also given as a 1 ampere. Just a very small two things you need to remember while solving this question, that the mu r into mu naught will give you the permeability of that particular material, and also a very small thing in this question, which is the second one, that the 1000 is not a total number of turns. 1000 is given as a number of turns divided by length, which we can say number of turns per unit length. Now by putting these values into the calculator, you can get the answer, which is a 16 pi into 10 raised to minus 2 given in the third option. Okay, let us move to the next question. A short bar magnet placed with its axis at a 30 degree with a uniform external magnetic field of a 0.25 Tesla experiences a torque of the magnitude which is equals to 4.5 into 10 raised to minus 2 joule. What is the magnitude of the magnetic moment of the magnet? What is the formula to find the magnetic moment? Because there is a torque, you can say the formula which connects the torque and magnetic dipole moment can be written as a tau is equals to mb sin theta. What is the value of torque? Value of torque is given as a 4.5 into 10 raised to minus 2 joule. Remember very well, my friend, that the formula or the unit of the torque is joule, but torque is not a work done. Torque is a type of the force which is a rotational force. And what is the formula of the torque? Formula of the torque is equals to R cross S, and it is not a work done. You have studied this in the standard 11 chapter number 7 rotational. This is not a work done, this is a type of force only. But because the formula of the torque is R cross F, that is why you are getting the unit as a joule. Okay, so now the value is given is equals to M. What is the value of capital M? Oh, we need to find that into magnetic field, which is given as a 0.25 into sin theta. Sin 30 value is 1/2. Just make this a subject, which gives the value M is equals to 4.5 into 10 raised to minus 2 into 2. Divide by 25 into 100, because it is a 0.25. 25 divided by 100, and that 100 goes into the numerator, so it becomes the 4. Just solve this, put the values in the calculator, and you will get the answer 1, which is 0.36. Okay. So next, a polarity of an induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. This statement is known as a, who gave this statement to us? Let us check it by option. Faraday. As we all know, there are two laws of the Faraday's in the 6th chapter, but that does not tell us that the produced EMF will oppose. What is the two laws? First says that it will produce the EMF, and second gives us the formula that EMF is equals to minus of d phi by dt. This much only two laws of the Faraday's tells us in the 6th chapter. So this particular statement is not given by the Faraday. Another option is a Maxwell. Maxwell comes in the picture in the 8th chapter of the standard 12, which is a electromagnetic waves. He completes the electromagnetic theory by saying that the changing electric field produces the magnetic field. We only knew, until that time we only knew that changing magnetic field can produce the electric field, but then Maxwell tells us that also changing electric field can produce the magnetic field, and after that the whole electromagnetic theory completes. This is what the Maxwell's role in the part 1 of the standard 12. Okay, so this statement is also not made by the Maxwell. Then there is a Kirchhoff. We all are very well aware, standard 12 chapter number 3. There are the two laws of the Kirchhoff in the electricity, which are KCL and KVL, current law and voltage law. There is no chances that any student will make the mistake on this option. And then we are remain with the only one option, which is a Lenz. Yes, Lenz made this statement that this EMF will oppose the change, and that is why you have this negative sign in the formula of the Faraday. So your correct answer becomes the fourth option, which is Lenz. Let us move to the next question, and the next question says a pair of the adjacent coil has a mutual inductance of the 1.5 Henry. Mutual inductance capital M is given. Sorry, if the current in the one coil changes from 0 to 10, change in current is given from 0 to 10, change in time is given 0.5. What is the change? हेलो हेलो હવે ડન આશીષભાઈ એકવાર તો ચેક કરી લેજો ને આવવા માંડ્યો છે ને ઓડિયો okay. So again, due to the technical issues, we are running out of the audio and we are back. So let us start with this question again. A pair of the adjacent coil has a mutual inductance of 1.5 Henry. If the current in the one coil changes from 0 to 10 ampere, change in current is given as well the change in time is given. What is the change of flux linkage with the other coil? So there are two types of the linkage. One is a self inductance, another is a mutual inductance. In the last paper also they have asked you the question from the mutual inductance only, and we have discussed the formula in that previous one also. So right now the formula of the flux becomes M into I, or we can say delta flux is equals to M into delta of the I. What you need to find? You need to find the change of flux, which will be equals to the mutual inductance. What is the mutual inductance? It is 1.5 into delta I. What is delta I? Change in current, which is 10. So your answer becomes simply 15 Weber, which is given in the third option. So the next question says an air-cored solenoid with length 30 centimeter, area of the cross sectional, okay, the length is given 30 centimeter, area of cross sectional is given 25 centimeter square, number of turns is given 500, carries a current of the 2.5 ampere. The current is suddenly switched off in a brief time of the 10 raised to minus 3 second. Change in time is given, which is 10 raised to minus 3. How much is the average back EMF induced? What they are asking you, they are asking the value of the EMF induced across the ends of the open switch in the circuit. Ignore the variation in the magnetic field near the ends of the solenoid. So first of all, let me give you a very few only a one line extra information which is not given in the NCERT. So there will be the change in the magnetic field in the solenoid at the end. At the end, the magnetic field will be half of the magnetic field at the center of the solenoid, and they are saying that you need to ignore that change at the end, which is actually half of the change inside the solenoid. So now what they are asking us the EMF. So the EMF is equals to L into di by dt. And what is L? It is a self-inductance of the solenoid. And what is the formula of the self-inductance? We have just gone through it in the previous paper. Self-inductance of the solenoid is equals to mu naught into n square into A divided by length of the solenoid. Put the values here. So it will be mu naught into n square into area divided by length of the solenoid into delta of current divided by delta of T, which is equals to mu naught, that is 4 pi into 10 raised to minus 7 into square of number of turns, which is 500 into 500 number of turns into area. What is the area? So the area is 25 centimeters square. So it becomes 25 into 10 raised to minus 4 divided by length of the solenoid. What is the length of solenoid? It is 30 into 10 raised to minus 2 into length into delta I. What is delta I? The change in current is 2.5 ampere divided by delta T, which is a 10 raised to minus 3. You just have the long numbers or a large number, but because you have a calculator in the GUJCET paper, I think this is not a bigger task. The only one thing you should be remembering while solving this equation, which is a value of the self-inductance, which is a mu naught into n square into area divided by length of the solenoid. Okay, you can solve this in the calculator, and after solving this number, you will get the answer, which is a 6.54 volt, which is given in the first option. Okay, next question. For an ideal transformer, if NS is greater than NP, then, so for the ideal transformer, you should be remembering the relations between number of turns and voltage. And there is also a relation between the current. What are those relations? So the relations is EP divided by ES, which is a voltage produced in primary coil divided by voltage produced in the secondary coil, is equals to NP divided by NS, number of turns in primary divided by number of turns in secondary, which is equals to IS divided by IP. This is the important relation, that current is inversely proportional with the number of turns. Don't get confused in this one, and don't make the mistake if they ask the question from this particular portion. So right now they are only asking us about the relation between the number of turns and the voltage produced, which is directly proportional. So if number of turns in the secondary is higher, we can say voltage produced in the secondary will also be higher. So we can say VS is greater than VP, which is given in the second option, which becomes your correct answer. Okay, let us move to the next question then, which says the charge 10 microfarad capacitor is connected to a 16 millihenry inductor. 10 microfarad capacitor connected to a 16 millihenry inductor. What is the angular frequency of the free oscillations of the circuit? Only in the last paper, just before the few time, we have discussed that there are the two type of the frequency. One is the angular frequency and another is the resonant frequency. And we have discussed the formula of both, and also we have derived the formula of both. Again, I am saying the angular frequency formula is omega is equals to 1 upon under root of the LC, which is equals to 1 upon under root. What is the value of L? Value of L is given 16 into 10 raised to minus 3 into value of capacitance, which is given as a 10 into 10 raised to minus 6. It becomes 10 raised to minus 9. So you can say it becomes 1 upon under root 160 into 10 raised to minus 9. Just make it as a 1 upon under root 16 into 10 raised to minus 8. And just by solving this thing, you will get the answer, which is in the question 41. The answer will be 2500 radian per second, which is clearly visible. After coming out of the root, it will become the 10 raised to minus 4 will goes into the numerator. So 10 raised to plus 4 divided by 4, which will be equal to 2500 radian per second. Okay, so let us move to the next question again. A light bulb is rated 200 watt for a 220 volt supply. Find the resistance of the bulb. Even a student of the 9th or 10th standard can solve it very easily. There is a formula in the standard 12 chapter number 3. P is equals to V square divided by R. What is the amount of power given? It is a 200 watt, which is equals to the voltage, which is 220 into 220 divided by the resistance. So now resistance R becomes 220 into 220 divided by 200. 0, 0, 0, 0 got cancel out. Just do it. 22 into 22 divided by 2, which becomes 11 into 22, and 11 into 22, which is a 220 plus more 22. Yes, so it becomes a 242. Yes, it is given in the third option, 242, which is your correct answer. Okay, next question. Sir, another silent karna. Okay, so the next question. A radio can tune into any station in 6 megahertz to 12 megahertz of the band. What is the corresponding wavelength band? What is given? Frequency is given, and what you need to find? The wavelength band, how they are connected to each other. Wavelength is equals to C upon F. Very simple formula. So lambda 1 is equals to C upon F1. Why I am not writing C1? It is a very obvious thing that it is fixed for all, which is the speed of light. What is speed of light? 3 into 10 raised to 8 meter per second. Now place the value for the first frequency. So it gives that 3 into 10 raised to 8 divided by the frequency, which is a 6 into 10 raised to 6. So I think it gives us 1 by 2 into 10 raised to 2, which is equals to 100 by 2. So it becomes a 50 meter. And for the second case, the frequency 12 megahertz. So now I can say lambda 2 is equals to C by F2, which will be equal to 3 into 10 raised to 8 divided by second frequency 12 into 10 raised to 6. So again it becomes 1 by 4 into 10 raised to 2, 100 divided by 4, which is a 25 meter. So what is the corresponding wavelength band? Corresponding wavelength band is between the 25 and 50. So our correct answer is second option, 25 meter to the 50 meter. Okay, let us move to the next question. Yes, a charged particle oscillates about its mean equilibrium position with a frequency of the 10 raised to 9 hertz. What is the frequency of the electromagnetic wave produced by the oscillation? They have given you the oscillation of the charged particle, and they are asking you the frequency of the wave produced. So the frequency of the wave and the frequency of the particle which is oscillating, both are same only. You don't need to pick up the pen even to solve this question. If the frequency of the oscillating particle is 10 raised to 9, frequency of the wave will also be 10 raised to 9. Which option is matching with that? Second option, 10 raised to 9 hertz, which is our correct answer. Okay, let us move to the next question. Light from a point source in air falls on a spherical glass surface for which refractive index is 1.5 and radius of curvature capital R is 20. The distance of the light from a source of the glass surface is 100 centimeter. From source to the glass surface, distance is given 100 centimeter, and we need to find the image distance. And to solve this question, you need to recall the formula. The formula is N2 divided by V minus N1 divided by U is equals to N2 minus N1 divided by R, where R is a radius of curvature. What is the question basically says? The question says that there is some particular light source, and at some distance we do have a curvature, this type of the surface. Light falls on this, and after that there is a refractive index of the 1.5, and they are asking us the image distance. This distance is given as 100 centimeter from the source to this whatever the surface of the glass is given. Okay. So now N2 is after the light entering into the another medium. The refractive index of that one is 1.5. So it is a 1.5 divided by V. That is what they are asking us in the question. Find the image distance. Minus N1. For the air it becomes 1. Divided by U. The U is the object distance, which is 100, is equals to N2 minus N1. 1.5 minus 1, which is 0.5. Divided by radius of the curvature. What is the radius of curvature? It is equals to 60. I have given you the formula. I have placed the values for that. Now calculate it further, make it a subject, and after doing this calculation for this question, you will get the answer as 100 centimeter. Okay. So let us see the next question. The next question says that double convex lenses are to be manufactured from a glass of the refractive index 1.55 with both the faces of the same radius of the curvature. What is the radius of the curvature required if the focal length is to be 20 centimeter? If the focal length is to be 20 centimeter, what should be the formula? The formula will be 1 upon f is equals to mu L minus 1 into 1 upon R1 minus 1 upon R2. And in case of 1 upon R1 minus 1 upon R2, they are saying that the both are the same radius of curvature, and if both are the same radius of curvature, one should be taken as a positive and one should be taken as negative. So here I need to apply one more negative, and this minus and minus will become the positive. So 1 upon, what is the value of focal length? 20 centimeter is equals to mu L. Mu L is a refractive index. What they are asking us? They are asking us the radius of the curvature. Is mu L given? Yes, it is given 1.55. So let us place the value of that, which is 1.55 minus 1 into 1. This minus minus becomes plus 2 divided by R. 1.55 minus 1, that is 0.55. And after taking that 0.55 to the another side, you will be only remaining 2 by R on this side. And after solving this simple thing, in this question number, you will get the answer as a 22 centimeter. Okay. Next question. What is the focal length of a convex lens of a focal length 30 centimeter in contact with a concave lens of the 10 centimeter? Remember one thing, if you do have a concave lens, this focal length should be taken as a negative. And if you have a convex lens, yes, the another is given as a convex, this should be taken as a positive value. And what are they asking? They are asking us the total focal length. So it becomes 1 upon f is equals to 1 upon f1 plus 1 upon f2, which is equals to 1 upon 30 minus 1 upon minus 10. This should be taken minus because it is a focal length of the concave lens. Minus minus becomes plus. So it becomes 1 upon 30 plus 1 upon 10. Just do the further calculations, and by doing this further calculations, you will get the answer, which is minus 15 centimeter, and it is given in the option number 1. We have get this type of the question. We have solved this in the previous paper also of the paper 2021. There was a question in which we need to use the formula 1 upon f is equals to 1 upon f1 plus 1 upon f2. Also there is a question in which we need to formula that 1 upon lambda is equals to mu L minus 1, 1 upon R1 plus 1 upon R2. So basically they are repeating the concepts. You just need to know the basic concept and the basic formula, and just by putting the values in it, you can easily score a very good amount of the mark in the GUJCET. So just solve these two papers of the 21 and 22, which will make a really good impact in your mark. Okay, so next question, question number 48. Unpolarized light is incident on a plain glass surface. What should be the angle of the incidence so that the reflected and refracted rays are perpendicular to each other? They are asking us the theta, and we all know that the formula is tan theta p is equals to reflecting index. What is the value of refractive index? Okay, is there no value of the refractive index? Okay, but this is about the plain glass. If it is about the plain glass, what is the refractive index? 1.5, or to be more precise, the refractive index of the glass is 1.48. So you can say that tan theta p is equals to 1.48. We need this theta p, so theta p becomes tan inverse of 1.4 L. You will be having a calculator, and also you will be having the log table in the paper if you need. After doing this tan inverse 1.48, you will get the answer 15 degree, which is given in your first option. Okay, let us move to the next question then. Next question. Two slits are made up of the 3 millimeter apart and screen is placed at a 2 meter away. Okay, if the screen is placed at a 2 meter away, that means the capital D is given. two slits are made. Distance between the two slits, that means the small d is given. What is the fringe separation when the blue-green light of the wavelength lambda is given? What should be the formula for that? The formula should be beta is equals to lambda into capital D divided by small d. All the three values are given in the question. Place the values lambda, which is 600 into 10 raised to minus 9, into capital D, which is 2, divided by small d, which is 3 into 10 raised to minus 3. Solve this further. That is no more calculation. This is a very less calculation. We have seen one or two questions which has a lengthy calculation. With respect to that, you can solve it very easily. And after calculate these terms in the question number, you will get the answer 0.4 mm, which is given in the first option, which becomes your correct answer. Okay, so next question, estimate the distance for which ray optics is a good approximation. Good approximation, we have entered in the Fresnel. For an aperture of the 5 millimeter, the wavelength is 500 millimeter. Again, the concept is repeated. In the previous paper also we have seen one question of the good approximation, and right now also there is a one question of the good approximation. For the good approximation there is a one simple formula which is equals to a square divided by lambda. Again I am saying they are repeating the concept, they are repeating the question which can be solved by the same formula. So just refer the 2 years of the paper. That is why Charvik Institute is delivering this kind of the videos in which you can also get the revision of the physics. How our videos are different from the other videos on the social media. They are only solving the paper, but we are solving the paper as well. We are revising the theories as well. We are talking about the how the types of the question, which type of the questions could be asked from the theories. So if you have just referred these two papers from our channel, you can easily score a good mark from the paper in the GUJCET paper. So again, for the good approximation, formula is a square divided by lambda. What is a square? A square is the aperture. What is the value of aperture given? It is 5 into 10 raised to minus 3 whole square. Divide by lambda, it is in the nanometer, so it becomes 500 into 10 raised to minus 9. Again, solve these 2-3 numbers, very small numbers, and after solving, you will get the answer as a 50 meter, which is given in the first option. Okay, next question. What is the de Broglie wavelength associated with an electron moving with a speed of the 6.4 into 10 raised to 6 meter per second? What should be the formula for this? Lambda is equals to h upon mv. What is h? It is Planck's constant. Even the value of the Planck's constant is given in the question. Even if you do not remember that value, also then you can get the answer. What happened? वीडियो बैटरी करना को चेंज भारे कई ऑडियो ऑन है सर जी ऑडियो ऑन है ऑडियो ऑन है ओके ऑडियो ऑन है ना yes students just wait for one more minute we just need to change the battery of the camera because the faculty of the chemistry has also solved the two papers just before me. So I think it took 2 or 2.5 hours for him, and also right now we are doing it from almost 2 and 2.5 hours. So we are running out of the battery of the camera. Just wait for 1 minute. Okay, we are on. Yes, is audio perfect? On? Okay. Okay, so we are back again. So I was saying that if you do not remember the value of the h, even that is given in the question. You just need to remember this small formula and you can grab the mark of this question. So we all know that the value of the Planck constant is 6.6 into 10 raised to minus 34 divided by mass. It is 9.1 into 10 raised to minus 31 into velocity. What is velocity? It is 6.4 into 10 raised to 6. Again, it was a very simple question. We have placed the values and by solving this with the help of the calculator, you can get the answer which will be 0.114 nanometer, which is given in the second option. Okay, let us move to the next question quickly, which says an electron, an alpha particle and the proton have the same kinetic energy. Which of this particle has the shortest de Broglie wavelength? So we all know that for the shortest de Broglie wavelength, lambda is inversely proportional with the mass. So the one with the highest mass or the higher mass will be having a shortest wavelength. And which of among three, alpha, electron and proton, which of having a higher mass? And it is a very obvious thing that none of this should not be the answer. If they have given you the three particles, it is an obvious thing that among from these two, one of is having a shortest wavelength. So there will be the answer from these three. What should be the answer which is having a higher mass? Which particle is having a higher mass? Alpha particle is having a higher mass. So first option becomes our answer. Okay. Move to the next question. A difference of 5.4 electron volt separates two energy levels in an atom. What is the frequency? What is the frequency of the radiation emitted when an atom make a transition from the upper level to the lower level? Simple formula again. E is equals to H into F. What are they asking? They are asking frequency, which will be equals to energy into Planck's upon Planck's constant. What is the energy? 5.4 electron volt. So we can say 1.6 into 10 raised to minus 19 of the joule. You should be remembering this little transitions of the unit, so that you will not lose the mark of the particular question. Let me tell you that 1 electron volt is equals to 1.6 into 10 raised to minus 19 joule. And what we have done here, the energy is given in the 5.4 electron volt. So if 1 electron volt is equals to this much joule, what about the 5.4 electron volt? So it will be equal to 5.4 into 1.6 into 10 raised to minus 19 divided by Planck's constant. Planck's constant is 6.6 into 10 raised to minus 34, and again which is given into the question itself. Okay, so now if you will solve this in the calculator, you will simply get the answer. Option number 1, 1.304 into 10 raised to 15 hertz. Next question. What is the shortest wavelength present in the Paschen series? Lyman, Balmer, Paschen of the three. Again, same type of the concept and not same type of, but same equation you need to apply as we have applied in the last paper. I am again and again saying they are repeating the concept, they are repeating the equation. Just solve these two papers with very carefully, with so much of the concentration, and you can get the answers easily. So right now we have a formula 1 upon lambda is equals to R into 1 upon Lyman, Balmer, Paschen. So it will be square of 3, which is equals to 9 minus 1 upon, okay, again they are asking the shortest wavelength. Even in the previous question paper, they have asked the question for the shortest wavelength. Even we have discussed there also that if you want the shortest wavelength, then you need to go to the infinite. So therefore it will be the square of the infinite, which term becomes 0. So now 1 upon lambda will be equals to R divided by 9, where R is a Rydberg constant, which is equals to 1.09737 into 10 raised to 7 m inverse. Place the value of the Rydberg constant, solve this in your calculator, and you will get the answer as 820 nanometer, which is given in the option number 4. Okay, so the next question says the radius of the innermost electron orbit of a hydrogen atom is given 5.3 into 10 raised to minus 11. What are the radii of the n is equals to 3 orbit? Again, we are passing through the same concept and same equation type of the question. There was this type of the question in the previous paper in which they have asked the radius of the fourth orbit, and right now they are asking the radius of the third orbit. Again, same type of the formula will be applied, that r of n is directly proportional to the n square divided by z. And as same as the previous year's paper, again they are asking it for the hydrogen atom, and for the hydrogen atom atomic number is 1, so we don't need to remember, so we don't need to worry about this z. We can simply say Rn is directly proportional to the n square. So r of 1 divided by r of 4, which will be equal to square of 1 divided by square of 4, that is 16. Fourth is what they are asking. So R4 is equals to R of 1, which is 5.3 into 10 raised to minus 11 is into 16. So 16 fives are, which is equals to 80. Okay, we are not getting the answer. So in the question number, it will be 9 into, okay, yes, the mistake is they are asking it for the third orbit. And for the third orbit, there should be the square of 3, so it becomes 9. And now you will multiply this given number of 5.3 into 10 raised to 11 with the 9. So 9 fives are 45. Yes, the answer will be in the order of the 4, which is given in the second option, 4.77 into 10 raised to minus 10 m. Okay, let us move to the next question then. Yes, in accordance with the Bohr's model, find the quantum number. Find the quantum number n that characterize the Earth's revolution around the Sun in an orbit of the radius with the orbit speed and mass of the Earth, and again h is given. So if you need to find the quantum number according to the Bohr model, there is a formula which is equals to nh upon 2 pi, and Bohr has also said that it will be equal to the angular momentum, which is mvr. So we can write the formula that mvr is equals to nh upon 2 pi, and you need to find the value of the n. So our n becomes mvr 2 pi divided by h. So the value of n will be equal to 2 into 3.14 into m. What is mass? Mass is 6 into 10 raised to 24 into what is velocity? Velocity, where is the velocity? Yes, 3 into 10 raised to 4 into radius. What is radius? Radius is 1.5 into 10 raised to 11 divided by h, which is 6.6 into 10 raised to minus 34. Again, solve this in your calculator, and by solving in this question, you will get the answer 2.6 into 10 raised to 74, which is given in the third option. Okay, next question. Given the following atomic mass, uranium, helium, thorium, calculate the energy released during the alpha decay. So during the alpha decay, we need to find the energy, and that energy can be found as E is equals to delta mc square. So what will be delta m? So delta m, you can say mass of the uranium minus the released, that means mass of the thorium plus mass of the helium, and into what is given 931.5, so it will become 931. So now mass of the uranium, don't consider the mass of the uranium as a particular 238. You need to take particular these values, otherwise you won't get the answer. So you will say it is 238.05079 negative of what is the about the thorium, 234.04363 plus what is it given about the helium, 4.00260 multiply with the 931. Again, solve this thing in your calculator, and by solving you will get the answer 4.25 mega electron volt. Question next. A radioactive isotope has a half time of the T years. half time of 30 years. How long will it take the activity to reduce by the 6.250%? The only change is this time they have given this value in the percentage. Otherwise, the question on the same concept as asked in the previous year's papers also. Now, if the value is in the percentage, you can say we can divide it by the 100. So 6.250 divided by 100 gives us 0.0625. So you need to make the activity this part from the original one amount. Okay, so now if you have a full amount or the full element, the activity will take the half of it. That means 0.5. Again, from this 0.5, the after the half time, it will be equal to 0.25. We can say 0.25, and after again the half time period, it will be 0.125, and then after again you will get the 0.0625. So how much cycles does it take? 1, 2, 3, 4. So after the 4 times of the half lifetime period, you will get this much amount in the percentage, which is 0.0625, and in percentage it is 6.250, which is after the 4 cycle. That means it is a 4 of the time period. Also, you can solve it by the equation that 1 upon 2 raised to n, and you will get the n as a number 4, which formula we have discussed in the previous paper also. Okay, so we are not wasting time on that thing. It is a very simple thing. Next question, the half-life of the SR is 28 years. What is the disintegration of the rate of the 38 gram of the isotopes? So we need to find it for the 38 gram of the isotopes, and to find it for the 38 time, we have a formula R is equals to N into lambda, where what is N? N is a number of the atoms, and what is lambda? You need to find the lambda. Are we out of the video, or is it on? Okay. So R is equals to N lambda. For lambda, you need to find it that tau 1/2 will be equals to 0.693 divided by lambda. So lambda will be equal to 0.693 divided by tau 1/2. So place the value of the lambda. And what about N? N is a number of atoms. How will you find the number of atoms? So atomic mass of the SR is 90. And because you have studied physics and chemistry very well, you guys are very well aware that this means that in the 90 gram of the amount, there will be the number of atoms which is equals to N, which is equals to 6.023 into 10 raised to 23. So if you have taken it for the 38 gram, how much number of the atoms will there be? So it becomes a 38 into 6.023 into 10 raised to 23 divided by 90. So these are the number of atoms which becomes the value of the N. You have a value of the lambda here. Place all the values in this equation. So instead of the N, we will say it is 38 into 6.023 into 10 raised to 23 divided by 90. And for the lambda, we can say it is a 0.693 divided by half time period. Oh, it is given in the years, so you need to convert it into the second also. How will you convert it? So for the 28 years, in each year there are 365 days, and to be more precise, there are 365.25 days, because after every 4 years you are getting a leap year. So now we are getting it into the days. So in a one day, how many hours are there? 24 hours. In 1 hour, there is a 3600 second. So now we have again done with all the values. In the each paper, there are 1 or 2 questions which have a higher number of the values. I am not saying which questions are tough. I am just saying which have a lengthy calculations. There will be the more numbers which compared to the other questions in your paper. So you just need to solve this, and by solving it in your calculator, you will get the answer, which answer will be equal to 5.7 into 10 raised to 14, which is given in the option number 4. Okay, so let us move to the next question. The circuit shown in the figure works as which gate? Again, we have a circuit of the gate. In the last paper also we had it one. This time also they have made the same type of the circuit from the gate. Let us solve it. So this is a NOT gate. So if you are giving input A, you will be getting A bar. If you are giving input B, you will be getting B bar. Again, I am repeating the Boolean expressions. For the OR gate, the Boolean expression is A plus B. And for the AND gate, the Boolean expression is A dot B. If you have a NOT gate, it will just change. If you are getting A, you will be receiving A bar. So just need to place the bar in case of the NOT gate. So A bar and B bar. There we have a OR gate connected with the NOT. So basically this is a NOR gate. So let us take it step by step. So for the OR gate, you can say it will be A bar plus B bar, and because there is a NOT gate also, there will be one more bar. So we are getting a Boolean expression as A bar plus B bar bar, and you know the relation that A bar plus B bar will be equal to bar of A dot B. Place this value in this equation, you will get the bar and bar of A dot B. This both cancels out and your answer of the Boolean expression is A dot B. And if you are getting the answer A dot B, which gate is it? It is an AND gate. So this circuit will behave as an AND gate, which is given in the option number 3. Move to the next question. When a forward bias is applied to the PN junction, it lowers the potential barrier. Very simple and theory based question. No need to discuss it in the detail. Just move to the next question very quickly. Okay, suppose a pure Si crystal has a 5 into 10 raised to 8 atoms. It is doped by 1 ppm. 1 ppm, that means 1 parts per million. Concentration of the pentavalent as arsenic. Calculate the number of the electrons and the holes. Now there is a slight printing mistake, not in our print, also it was in the paper of the GUJCET, that you need to just calculate the number of the holes and not the number of the electrons. So let me just remove first the number of the electrons. Okay, doesn't matter. We all know now that you need to calculate the number of the holes. So before calculating the number of the holes, there is a doping in the 1 parts per million. That means in 10 raised to 6, there will be 1 electron parts per million. That means 10 raised to 6. Then how much electrons will there be added in the 5 into 10 raised to 28 atoms? So it becomes 5 into 10 raised to 28 divided by 10 raised to 6, and 28 minus 6 becomes 22. So it will be 5 into 10 raised to 22 electrons. You have a number of electrons. Apply the formula Ne into Nh, which is equals to Ni. Ne, you have got it. Ni given into the question. Place the values and derive the answer. By solving these numbers, you will get the answer in this question, which is 4.5 into 10 raised to 9 m raised to minus 3. Okay. Next question of the dimensional formula. In the last paper also there was a question based on the dimensional formula. Which question was there? They were asking the dimensional formula of the electric potential V, which we have done it by the P is equals to Vi, and therefore V is equals to P divided by I. Let us see right now what they are asking. They are asking the dimensional formula of the electric flux. What is the formula of the electric flux? The electric flux can be written as a EA into cos theta. We don't need to consider cos theta for right now, as theta is a dimensionless quantity. And let me tell you for your information and for the revision, there is a magnetic flux also. And what is the formula of the magnetic flux? It is a BA cos theta. And what is cos theta? Theta is between B and A, where A is the area vector. Theta is between magnetic field and area vector. But right now to solve this question, we just need the formula. Flux is equals to E into A. How can we write the electric field? We can write the electric field as a force divided by charge into the area. What is the dimensional formula of force? It is M1 L1 T minus 2. If you don't remember it, you can get it by F is equals to M. How will you write the dimensional formula of the charge? So there is a formula, I is equals to Q by T. So Q is equals to I into T. So instead of the charge, we can say A1 due to this I, and because of this T, we can say T of 1 into the area. Area is a meter square and meter is a part of the length, so there will be L2. So now your final answer will be M1. This L will be added to this one, L3. This 1 will go in the numerator and becomes the -1, and -2 and -1 becomes -3, and this A will go in the numerator and it will become A -1. So answer is M1 L3 T -3 A -1, which is given into the option number third, M1 L3 T -3 A -1, yes, which becomes your correct answer. So let us move to the next question after this easy question. An electric dipole with a dipole moment of 4 into 10 raised to -9, this is not centimeter, C should be capital, coulomb into meter, is aligned at a 60-degree angle is given with the direction of a uniform electric field of the magnitude of the electric field is given. Calculate the magnitude of the torque acting on it. What is the formula of the torque? Torque is equals to PE sin theta. What is the dipole moment? An electric dipole moment is this one. The direction of the uniform electric field. Okay, value of the P is given 4 into 10 raised to -9. Value of electric field is given, which is 5 into 10 raised to 4 into sin theta, sin 60, which is √3 divided by 2. 2 and 4 gets cancelled. Again, just place the values, just do the calculation, and after the calculation in your calculator, you will be getting the answer second, which is 1.73 into 10 raised to -4. Okay, so let us move to the next question. An infinite line charge produces an electric field of 9 into 10 raised to 4. This much amount of the electric field is producing at a distance of the 2 centimeter. Calculate the electric field produced at a distance of the 3 centimeter. What is the relation between electric field and the R? So E is equals to lambda upon 2 epsilon naught R. Therefore, we can say electric field is inversely proportional with the distance. So from this proportionality relation, we can say E1 upon E2 will be equal to R2 divided by R1. What are they asking? They are asking electric field at some other distance. So equation of the E2 becomes E1 into R1 divided by R2. Value of the E1 is given, which is 9 into 10 raised to 4 into R1. What is the value of R1? It is 2 into 10 raised to -2 divided by R2. It is 3 into 10 raised to -2. -2 cancels out each other. 3 3s are 9, 3 2s are 6. 6 into 10 raised to 4, which is the correct option. You don't need the calculator even for this thing. Only if you know this simple formula, you can say the answer is 6 into 10 raised to 4. Okay. Let us move to the next question. The next question says, how will you connect 4 capacitors? You need to connect the 4 capacitors, each of a capacitance 4 microfarad for having the equivalent capacitance of the 1.6 microfarad. Now, in this case, you need to check it option by option. Okay, but before checking it option by option, you should be getting the idea that if you will connect it in the series as well, if you will connect it in the parallel, in both the cases, you will not get the answer 1.6. Let us verify that thing. If you connect the 4 capacitors in the series circuit, they will behave as a 1 upon C equivalent is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4. We have discussed these formulas in the first paper also. And each of a 4 microfarad. And if each of a 4 microfarad, it will become 4 divided by 4 is equals to 1. But you aren't getting the answer 1.6. Now, if you connect them into the parallel, so in the parallel, you just need to add the total capacitance value of all of them. 4 plus 4 plus 4 plus 4, which is equals to 16. Again, you are not getting the answer 1.6. So let us take the other option. And if you will check the other option, let me just clear it. Yes. So in the first option, they are saying that 2 in parallel and 2 in series. First of all, this is not the correct answer. This is not the correct answer. And right now we are checking this first option, 2 in parallel. So 2 in parallel and 2 in series. 4 and 4. 4 and 4 in parallel becomes 8. So it will be capacitance of the 8. Here it will be 4 and here it will be 4. Now if I will solve it, all the capacitors are connected in the series, and for the series connection we can say the equation is 1 upon C is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3, which becomes 1 upon 8 plus 1 upon 4 plus 1 upon 4, which becomes 1 plus 2 plus 2 divided by 8, which is 5 by 8, and by taking the reciprocal it will be 8 by 5, and 8 by 5, as you can see, it is a 1.6. If you don't know it, just do it in your calculator. The 8 by 5 will be exactly 1.6. So your answer becomes the first option. If you will connect the two capacitor in the parallel and two capacitor in the series, you will get the equivalent capacitance of the 1.6 microfarad. Okay, so let us move to the next question then. A slab of a material of a dielectric constant 3. The K is given, dielectric constant. Which chapter is it? It is a chapter number 2, standard number 12. And the value of the K is given. Same area as the plate of the parallel plate capacitor, but the thickness. What is thickness? Thickness is denoted by the T. And where D is a separation between the two plates. What is the electric potential difference between the plates when the slab is inserted? So there is basically a capacitor, a parallel plate capacitor, and then they are saying that they are adding a slab of the dielectric material. So the separation distance between the plate is D. Now they have a dielectric materials slab, and which slab has a thickness of 3 times 4, 3 divided by 4 times D, which is approximately this much. And they are adding this slab of the dielectric material into the two plates of the capacitance. And when they will add this dielectric material between this, they are asking what will be the change in the electric potential. So we have a formula to find the change in capacitance first, that is A epsilon naught divided by D minus T into bracket 1 minus 1 upon K, where K is a dielectric constant, T is a thickness of the slab, D, you all know it is the separation distance between the two plates. A epsilon naught, A is the area, epsilon naught we all know permittivity of the free space. Now if you will place the value of the T as a 3 by 4D as it is given in the question, and you will solve it, you will get it like a 4K divided by K plus a 3 into C naught, where what is C naught? C naught is a epsilon naught divided by D. Why am I not solving this question here? Because it is the exact question which is given in the NCERT example number 2.8. If you will solve this by placing the value of the T as a 3 by 4D, you will get this perfect, which is 4K divided by K plus 3 into C naught. Now, up to the here it is given into the NCERT. Now, what they have done it further, they have given the value of the K, which is 3. Now, place the value of 3K here. So, it will become 4 into K, which is 12, divided by K plus 3. 3 plus 3, which is 6. So, it becomes a 2C naught. So, you will get the answer 2C naught. Now, what is C naught? You all know Q is equals to CV. So, C becomes a Q divided by V. So, we can say it becomes a 2 into Q naught divided by V naught. What was the capacitance before adding the dielectric material? Before adding the dielectric material, the capacitance was Q naught divided by V naught also. Now, what is the change in the capacitance? So, the change in the capacitance is a 2 times. But they are asking in the question that you need to find the change in the potential. So let me tell you friends, when you add the dielectric material, there will be a change in the potential only. The charge on the plates of the capacitor will not be reduced or the increase, but there will be another electric field which is in the opposite direction to that of the original electric field, and due to that thing original electric field will decrease, and due to the decrement in the electric field potential will also decrease. So we can say there is a change in the potential only. So I can write this equation as something like this, which is Q naught divided by V naught divided by 2, and then this 2 will come into the numerator. So what is the change in the potential? Change in potential is V naught divided by 2, which is given in your third option. This was a good logical question, we can say. Okay, so after passing that, let us see the next question. A molecule of a substance has a permanent electric dipole moment of a magnitude. The dipole moment is given 10 raised to minus 29. Again, this is not centimeter, this is capital C into M. The 2 mole of the substance, 2 mole of the substance has taken of this substance is polarized by applying a strong electric field of the magnitude 10 raised to 6. What should be the potential energy of it? What is the formula of the potential energy? Formula of the potential energy is equals to minus P into E. And because you have fully polarized this, the theta will be, you don't need to worry about the theta. So now our energy becomes minus P into E. What is the value of the P? So let us say they are saying that the electric dipole moment of a one atom or the one molecule is 10 raised to minus 29, and they have taken a 2 mole of this substance. Where is the 2 mole? Yes, here it is, 2 mole of the substance. So what is the number of atoms in the 1 mole? 6.023 into 10 raised to 23. And they have taken it twice because it is a 2 mole. So the number of atoms will be 2 into 6.023 into 10 raised to 23. This is the amount of the atoms we have taken. Now the one atom has a dipole moment of 10 raised to minus 29. If one has a dipole moment of 10 raised to minus 29, this much will be having what amount of the dipole moment? You just need to multiply this both the values. So you will get minus of 2 into 6.023 into 10 raised to 23 into 10 raised to minus 29 multiplied by the electric field, and electric field is given as a 10 raised to 6. Solve this in your calculator, and after solving it, you will get the answer of this question, which is equals to minus 12 joule, which is given in the second option. Okay, let us move to the next question quickly. Don't get bored and quit the video. This is your last and very last hard work. If you will do the hard work in these days, it will help you in the GUJCET paper, as well it will help you in the NEET papers. So stick to the chair. We are only remaining with the 1, 2, 3 and 4 questions only. After that, we are done with the revision of the physics, almost very much theories of the physics, and also we will be done with the solution of the last 2 years of the GUJCET papers. Okay, so without wasting your time, let us move to the next question. So this question says the room temperature, which is 27 degree, the resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is to be found 137, given that the temperature coefficient of the material of the resistance is 1.35 into 10 raised to minus 4. Temperature coefficient means alpha is what they are asking, and change alpha is what given, and what they are asking change in temperature. So what is the equation which is related to the amount of the resistance and change in the temperature? So you very well know it is given in the 3rd chapter, standard number 12. The formula is R is equals to R naught into bracket 1 plus alpha into T2 minus T1. What is the resistance after the change? It is 100, which is equals to original resistance 137. 1 plus value of alpha, it is given as a 1.35 into 10 raised to minus 4 into bracket T2, that is what we need to find, minus T1, which is 27 degree. Again, you have the equation. I have placed the values. Just use your calculator and get the answer for this, and you will get the answer 2767 degrees Celsius in this question. Okay, so let us move to the next question. Last 3 questions, guys. Okay. So what they are asking, the circuit is given, and for the given following circuit diagram, the dissipated electric power is given, which is 150 watts, and find the value of the resistance. In the above given circuit, there are 2 resistance. The value of one is given as a R, and value of other is given as a 2 ohm. Also the voltage is given in the diagram, which is 15 volt. And what you need to find? You need to find the value of the resistance. So for this circuit, because the resistance are connected in the parallel, we have a formula P is equals to V square divided by R. But what will be the R equivalent of this circuit? Because both the resistors are connected in parallel, you can say multiplication of both, which is 2R divided by addition of both, which is 2 plus R, which is equals to the R equivalent. Place the value. What is the power? Power is 150. 150 is equals to square of the voltage, which is 15 into 15, divide by R equivalent, which is 2R, and divide by 2 plus R comes in the numerator. Again, this 15 cancels out with the 150, and this becomes 10. 5 2s are, 5 3s are. So it becomes a 4R is equals to 6 plus 3R. So it will become 4R minus 3R. And after solving this equation, you will get the answer 6 ohm. Okay, so let us move to the next question. Okay, is it the same question? Okay, yes, here we are with the next question. So it says the number of density of the free electron in a copper conductor is estimated as 8.5 into 10 raised to 28. How long does an electron take to drift from one end of a wire, which is a 6-meter long? Length of the wire is given to its other end. The area of the cross section is also given, and it is carrying the current of the 1.5. So this is the question related to the relation of the current and the drift velocity and area, or all of these quantities. What is the formula to find this? We have already gone through this equation. I is equals to NEAVD. But what are they asking actually? They are asking that how much time will it take to travel for the electron. So how will you get the time from this equation? There is a velocity, and velocity is directly connected with the time, my friend. What is the formula of velocity? Velocity is equals to x by t, where what is x? It is the length of the wire, which is given in the question. So place the value I is equals to NEA into length of the wire divided by time. Now you want to find the time. Let me just clear it. Okay, now if you want to find the time will be equal to NEA into D divided by current. What is N? N is given in the question, which is 8.5 into 10 raised to 28 into E. We all know the value, 1.6 into 10 raised to minus 19 into area of cross section. Where is the area of cross section? Yes, 1 into 10 raised to minus 6 into how much the wire is long? It is a 6-meter long. Divide by the amount of current. What is the amount of current? It is 1.5. Just a simple and very small concept you need to apply in this question, that velocity is equals to distance upon time, which is very well known by all the students, and you have gone through this equation in the standard 11 chapter number 3 only. Okay, so solve this in your calculator and you will get the answer, which will be equal to 5.4 into 10 raised to 4 second. Okay, so let us move to the next question. What another thing they could ask you from this? They could ask you this time period into the minute. So you need to convert it from the second to the minute. You all know 60 seconds is equals to 1 minute. So this much second is equals to how much minute? Okay. Next question. Is it the last question? Yes, it is the last question. Okay. So a solenoid of the length of the solenoid LS is given, has a radius of the 1 centimeter, R is given, made up the 500 turns. It carries the current, value of current is 2.5. What is the magnitude of the magnetic field inside the solenoid? We have gone through almost 2 to 3 times in this 2 paper that the formula of the magnetic field inside the solenoid is B is equals to mu naught Ni, where small n is equals to total number of turns divided by length of the solenoid into current I, which is equals to 4 pi into 10 raised to minus 7. Total number of the turns which are given as a 500 into the current is 2.5 divided by the length of the solenoid. So length of the solenoid is 0.25. So simply I can say multiply by 4, because it will become 0.25 divided by 100. That 100 will go into the numerator and 25 for 100. Just multiply this, all the values, and by multiplying it in your calculator, you will get the answer, which will be equal to 6.28 into 10 raised to minus 3 Tesla. Okay guys, so here we are done with the papers of the 2021 and 22 of the GUJCET paper. I hope you have revised very much of the physics, and also if you have solved this question, it will actually boost your mark in the GUJCET paper. So to all the students who will be appearing in the GUJCET paper, whether they are from the Charvik Institute or not from the Charvik Institute, I myself and all the team of the Charvik Academia is wishing you all the very best. Just fill your paper with a cool mind. The paper is very easy all the time, and we are very sure that you will be getting a very good marks in it. Thank you very much for watching.